So today we are going to start, I think exponential and logarithm was left, right? So these two functions, I would say function, it means a mathematical relationship. So these two functions are very commonplace in our day-to-day life, which we generally don't see. Okay. So I would say the exponential term is very interesting to see. If you try to boil the milk, the level of the surface of the milk will remain stagnant for a very long time, although it rises very slowly. And just near the boiling, you can see that it will suddenly grow to the top of the container, right? So now you can say that, okay, this is the behavior which if you take the entire duration which it takes to boil, almost 95 or 98% of the duration, it is almost looks like it's stagnant, and then suddenly you see a sudden rise. So this can be interpreted as something like exponential behavior. Now we can talk about the logarithmic behavior or logarithmic scale actually. So there are many reverse situation. Okay, the reverse situation. Okay, first I'll start with the exponential growth story. So we have something like nuclear fission reaction in which a big nuclei disintegrates into smaller nuclei. So if any single object disintegrates into two objects, or let's say if we talk about the growth of bacteria, if we talk about the mitosis meiosis process, so if every cell will disintegrate into two cells, so you can see in the beginning we have one, then we have two, and then after that what we have is again four, and then next will be if each cell will disintegrate. So this kind of chain reaction is in nature we call this as exponential behavior. So whenever things like this goes on increasing, we say it is growing exponentially. Now the question is how we interpret this exponential behavior. If you talk about the nuclear fission reaction in which a neutron is bombarded on a heavy nuclei, and once this neutron bombards, it disintegrates the nucleus, and as well as it creates three more neutrons. And then again, this three neutron is capable of hitting three separate nuclei. And the next stage will get the nine neutrons getting generated. So again, such kind of growth, what we can call such growth as exponential growth. Okay. So growth, if you look from one direction, it is called exponential. But if you look from the other direction, if I reverse the direction, we call it logarithmic growth. Okay. Now, what is the best example of logarithmic growth? So let's say if you are shouting, let's say one person is shouting. Shouting means you are just creating some noise. And in a room, if one person is shouting, there is a level of some noise. So what happens if you come across, let's say in a room, if 10 persons comes together, then generally what do we expect? The noise level will become 10 times, right? But that is not so. If 10 becomes 100, what will be the noise level? So it is found that experimentally, or you can say it is observed that as the person will increase, the noise level never increases in that fashion. So the increment of noise always occur in the logarithmic fashion. It means to make a change of just to double the noise level, we have to take almost 10 times the actual level of actual number of the person who is creating the noise. Let's say if 10% is creating some noise, to double the noise level, I have to take 100%, and to triple, I need 1000%. Okay. So as the number is growing exponentially, the noise level is growing. We call it logarithmically. Now this is again a very observed phenomena, and in a chapter of sound, we will study something called loudness, in which we have the logarithmic scale behavior. So there are many cases, not only this. I mean, the entire physics is filled with a lot of logarithmic function, lot of exponential function, and therefore it is necessary that we must understand this process. You can always assume that the exponential and logarithm are same process in a reverse fashion. In a way, you can say it is a way of looking at it. So if you look in the growth side, it is called exponential, and if you look on the other side, it may be called logarithm. So we'll see all those things in detail and how we actually understand it. Now, when I say exponential function, what does it mean? What is exponential? So let's call exponential function. So any function in which the base is a constant. Let's say if you choose any constant, the only condition is the constant should not be equal to 1. So if you choose any constant which is not equals to 1, and if you raise its power, so power is the some variable, then any function which we express in this fashion we call exponential. For example, if I write 2 to the power some variable, let's call it x. This is called exponential function, in which the 2 is called the base and x is called the power. So when base is constant and power is variable, we call such function as exponential function. You can also write 10 to the power x. This is again called exponential function. And there is one very famous base that we come across, and that is called e. And this e has been inspired from the shape of the spiral, the shape of the galaxy, the shape of the history of e. Actually, you can read about it on internet. So the e is a symbol that we got inspiration from various shape in nature, which follows the exponential behavior. So e power x is also called exponential function. Now, generally, many of us think that okay, e power x is exponential, which is not true. Exponential word refers to any base, which is of course non-zero, or you can say which is a positive base, but it should not be equal to 1. In such case, when you raise the power, it will explode in its value very quickly. So 2 power x is also exponential, 10 power x is also exponential, e power x is also exponential. In the world of computer science, because we use the binary variables, we use 0 and 1. So the base 2 is a very common base that we use there. So every calculation in computer science follows the base 2 relation. If you come to the decimal system means, what is the decimal system? So decimal system is in which we have 10 variables. And what are the variables? Can you guess? In the decimal system, the variables are 0, 1. So these are variables, actually, these are symbols. So we create a world of number system using these variables. And so to deal with the decimal system, 10 is assumed to be a very nice base. So depending on the kind of base that we use, we can create any base and we raise the power, and we call such system or such function as exponential function. So when we talk about the logarithm, it is the inverse process. So logarithm is the inverse process of exponentiation. So what we do in case of a logarithm, sorry, and of course we take as positive also. So when you write a, so log of some number to the base a, and let's say this is equals to some value called x. Can you decode the meaning of this? What is the meaning of this log a, b, x, all this thing? So the a is called, it's just a way of writing. See, there is no meaning of it. You have to interpret the meaning as per the definition. So when we write something like this, log b a, so we are trying to convey two messages. What is the, this is a is representing the base. Let's write a reverse fashion. This is not better. Log like this. So the b is called what here? B is called base. Now this base is exactly this one. If b represents the base, then what x represents? This represents power. Then what a represents? Can you tell me what a represents? So a represents the number which you will obtain if the base is raised to the power x. Once again, a is the number which we obtain if the given base is raised to the power x. Then whatever you get is called a. For example, 2 power 3. How much is the value? So 2 power 3 we can write as. Hello, hello. Am I audible, guys?
Yeah, 8.
So 2 power 3 is?
8.
Sir, 8.
So why not saying? So 2 power 3 is 8. 2 power 4 is how much?
16.
2 power 5?
32.
So these are numbers. This is your a. What is the base here? Sorry. What is the base here? The base is the 2. And 3, 4, 5 here is the power that we are writing here. So the question is, when you write logarithm like this, you try to explain something to the world that if you take b as a base, then what power of a b will give me the number a? That's the question actually. So when I'm writing log 8 2, what should be the answer? Log 8 2, what does it mean?
So 3.
3. So it means what power of 2 I must write to get the 8. So we know the power we have to write. You have to write the power is 3. So you ask the power. So asking the logarithm means asking for the power value. So when you write log a, what should the answer?
So 1.
1.
That's logical.
1.
Because to get a by raising power to the a, the only power should be 1. But if I write it like log 1a, what should the answer?
0.
In fact, any base, if you try to find log of 1 for any given base, the only answer possible is
0.
so. These are like logical questions, like what power we must raise to the base to achieve the number that we are writing there. So that's why when you write log of a base b, you're trying to say that what base, the given base, what power that we must raise to the base to get the number called a. So what should be this answer?
The 2.
That's logical. So you want to achieve a square and the base is a. So I'm directly asking the power only, no? Correct? So we are directly asking what is the power. So here the log a of a square is going to be 2 only. So if I ask you what is the log of a power m, the answer going to be m directly. So that is the simple meaning of log. I think from the perspective of physics, the only meaning of log that you need to understand is the power, the base, and the number. Now, what is the condition on the base? What we cannot take the base? Can we take base as 1? Can we take base as 1? Yes or no? Hello, guys. Can we take base as 1?
No, sir.
So a1 is not possible. So we cannot take 1. So there's a condition on logarithm. So when you write log of base b of number a, then the condition or the constraint on b is what? B should not be equals to 1 and the value b must be positive. Understood? Okay, can you take b as a fraction? Can we take b as fraction?
Yes, sir, we can.
We can take the fraction as a base. So fractional base is possible. Now, if you take a fraction as a base, what will happen? So let's say if you write a 1 by 2, and let's say you want to achieve 2, what will get? So we can write this as 2 power minus 1. So what power of this to get to?
Minus 1.
Minus 1. Now what you will realize that once you take the base as fraction, the number can be negative also. It means we need to have the negative power to get that number. So of course, for all this relation, there's a rule given. So some properties of logarithm that you should be aware of. So what will be the logarithm of product of two numbers? Let's say if I want to write some base, so I'm writing some base b, and then we have two numbers m and n. So what is the logarithm of product of two number to the base b? So property simply say that if you have product of two number, you can write each number separately and simply add them. Okay. We're supposed to add the values. So m into n we can write as log of m plus log of n. Keeping the same base, we can write the sum. So you can also think that okay, if we have some base and the power is something, how to say this? Okay, I think proof is not required. Now, if we have something like log m is to n, what we can add then? M into n.
Log m to the base b minus log n to the base.
So when we have the difference, we can add as m n power minus 1, right? And so keep the same base. If we have anything like m power n, so m power n means we are multiplying m into m into m. How many times? N times, correct? And if you use the product rule, what you can get is log m. Log m. How many times? N times. So you're adding same number n times. Can we write as n log n? So in a way, you can remember this way that the power gets multiplied in the logarithm. So log of any base of a number which is written as m power n, you can write as n log of that number. So power gets multiplied. That is what you can always remember. This is very helpful. You can use this space also. There is something called the base change formula. Base change formula. You can also change the base. So as per the base change formula, what you can write? So if you want to change the base, this is simple. Let's say we have A, B, no, B. Let me put a heading first. Base change formula. So log of BA. Let's say you want to introduce some new base. So we have to write this as log of B. I'll keep this space empty into log of A, and I'll keep this space empty. And then you can introduce a common variable at both places. So let's say if you want to introduce anything, let's say C. Then log of A by, log of A base B, you can add as log of C base B into log of C base A. So this way of changing the base is also possible. We have one more relation, that log of A base B. I think we can also write as log of A and log of B with any new base. So this you can reconvert into log of A base B C and log of B base C. So there are many formulas in logarithm which you can write. So one particular base that we are interested in physics is called the natural logarithm. So when the base becomes the E symbol and you write any number x, this way of writing is called the natural logarithm. It is also called the Neperian Euclidean logarithm. So base is e. And what is the value of e? So e is a number which is roughly equals to 2.718. So of course it's a irrational number. We don't have the exact answer for this. And e is written as basically as a sum of fraction 1 plus 1 by factorial 2 plus 1 by factorial 3 plus 1 by factorial 4. The sum of all such number we call it exponential or e. And therefore, if you keep on adding like this, you will eventually get it will never end. So this is like irrational number. So e is a very famous number, and roughly you can remember as 2.72 also, or 2.718 is the famous answer. And in calculus or in physics, when I say logarithm, we always understand by default base e. If I have to mention other base, then that base should be mentioned explicitly. And this we rewrite as ln x. So we don't write log or base e. When I write ln x, it means the base is e. That is the only thing that you need to remember. So in a logarithm, ln x basically means log of x base e. That's it. Okay. E power x, that we call the exponent or exponential function, it will have a very nice expansion which you need to remember. And we write as 1 plus, I think it will become 1 here. I'll just put one more step. One plus one. So it is 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3, and it will keep on going up to infinite terms. And therefore, if I subtract 1 here, what will I get? X plus x square by factorial 2, x cube by factorial 3. And if I divide by x both sides, if I divide by x both sides, what will get happen? It will become 1 plus x by factorial 2 plus and now I'll introduce something called a limiting case. So if okay, limit I haven't, but anyway, if you know, if x is a very small number, if x is approaching a number as good as 0, then this entire term will become. So you can see if you put x equals to 0, all this term will vanish. So what we left with? 1. So this is again a very famous relation. Exponential is also written as limit a number n tends to infinity, 1 plus x by n power n. So if n is really large number, then this way of writing is also called exponential. Again, exponential is written in 1,000 ways. Just 1 or 2 ways you all should be aware of. The best, I mean, the most important part is the expansion. This series expansion of exponential. In maths, you will study something called the Maclaurin series and the Taylor series, and that series will give you the formula to evaluate this expansion. So we will study later on in calculus. Okay, so just remember these basic ideas. Also, you can say that for a small number, this is other way of writing. Every exponential can be written in a linear form. So e power x is although 1 plus x by factorial 1 plus x square by factorial 2, but for any small number, if it is really small, if x is very small compared to 1, okay, if it is a small number, let's say if mod of x is very small, in such case we use the approximation that e power x is as good as, we only keep the first two term, rest is so small that if x is very small, then the moment you square it, it becomes even smaller, right? So let's say if x is 0.001, so if you square it, it becomes 0.00001, which means it is highly insignificant compared to the x. So we can ignore, and this is called the approximation formula for exponential. So this we write as exponential formula. Now any number can be written in terms of exponential. How we write? We write e to the power ln of that number. So in case if you want to use the exponential relation, this is the formula. So you can write any number as e power ln a. Okay, so it's the same thing. So every number can be converted into e to the power ln of that number. Ln is the base, and therefore you can also write a as because e power ln a. So again we can use the exponential relation 1 plus ln a by factorial 1 plus ln a whole square by factorial 2 and ln a whole cube by factorial 3. So number can be written itself like this. Okay. So all these approximation, all this expansion, eventually everything will reduce to simple thing. So this is, I think, sufficient that you should be aware of from the logarithm. Okay, we are done with the basic of logarithm. If you have any doubt, you can ask. From logarithm, any doubt? I hope you understood the basic thing, like what is base, what is power. So in exponential or in logarithm, the only thing that we need to understand is the base concept and the power concept and the restriction on the base. Okay. So we can move towards the calculus now. So you can see the calculus itself means to calculate something, right? It's like calculate. So in calculus, we have many things. So we have something like a relation, or I'll start from even basic. Set, relation, function, also called mapping. Then we have derivative. And of course, in between we also have the limit or limits, continuity. We have something called differentiability. Derivative, antiderivative, you can say integral also. And then in the last we have differential equations. Or maybe something more, you can say it is. Of course, I'm not going to go into in detail of anything. I'll just give you a small idea about everything. What I need to explain the basic concepts. So what is set? In mathematics, what is set? I think you have studied in class 9. Tell anyone what is set?
So we can say it is a collection of elements or certain numbers.
It is a collection of well-defined objects. So set is a collection of well-defined object. So when you say sofa set, so you have sofa and the side chair and maybe some other chair. You say teapot set, so again you mean saucer and cup and so on. So when you say set, then you mean something which is related to each other in one way or the other. The random collection we don't call set. So if you have a collection of a cup, a pen, and some upholstery, and then some books, we don't call it set because we cannot define its property distinctly that it belongs to something or not. So when I say set, then mathematically it means it is a collection of well-defined, something which you can define, and they fall in some category actually. How we represent set? So to represent set, we use the curly bracket. And then again, there are two ways of representing. One is like you just write the elements. Or what you do next is you explain the property. Okay. So how you write the property, that's called the roster form. So you say a set, you give the name of the set. So you write the set before this vertical line. So let's say, so this is a X is a set of numbers such that, now how we read this line as? So this line is like a filter, like which kind of guys will come to this category. So what you write after the vertical line is called the filter. Okay. Or you can say definition of filter, like how to filter those numbers from the world of numbers, which can fulfill certain condition, and then it will be put into this X field. X is like some sort of packet. So in X packet, you put something based on certain definition, which you put on the right of the vertical line. So you say X, it is a set of number such that X, no, this is a modulo operator. Which basically means if X is divided by number 2, then the remainder will be 0. So it's an even number. I can write also this as X belongs to, now again you can write X belongs to even number. So there are ways of writing. So on the vertical line, what you write on the right side is the definition, like the filtering mechanism. What will be the filtering mechanism? So X is of course we have infinite numbers. So what kind of number I want to put in this curly bracket? So then you'd say, okay, those who belong to something like this or that. So that's called the roster form, in which you write the properties actually instead of writing the values. In the first form, we write the values that we want to put actually in the set. Okay. Is set ordered or unordered? Set is what? Ordered object or unordered object? Set do not follow any order, right? Set do not follow order or ordered sequence, which means if I write 1, 2, 3, or if I write 2, 1, 3, or if I write 3, 1, 2, are these different set or same set?
Same set.
Yeah. So what really matters is the element. It really doesn't matter how you write which comes first, which comes second. So the order doesn't matter in case of set. How we graphically represent the set? So to represent the set graphically, we draw some oval shape object, and you call this is set A. Just name it. So you put some name to it. The name can be a single alphabet. It can be full name also. You can add name, and then you simply write the element which you want to put in that set. So you can say 1, 2, 3, 4, and so on. You can put a number. You can put a non-number object also. So in reality, when we say set, you can put anything. Let's say you can put the name of the states of a country. So you can say Maharashtra. You can say MP, UP, Karnataka, Tamil Nadu, and so on. You can write anything. So of course, these are meaningful objects. So set is simply represented by you can take a oval shape object, just put anything inside which is well defined. We call it set. So graphically, this is how we represent the set. And the next comes is called the Cartesian product of two set. Cartesian product of two set. And how we represent the Cartesian product? A cross symbol, then B. So this is how we write the Cartesian product. And let's take some example. Just say A, we have a the set A in which we have name of the states. I'll just take the first alphabet: Maharashtra, MP, UP, Karnataka, and Tamil Nadu. And what is the capital of this state? What is Maharashtra capital? I don't know. Tell me. What is the capital of Maharashtra? Come on, guys, tell me. This is too much. I will throw out of the class.
Mumbai.
What is the capital of Maharashtra? Siddhant.
So Mumbai.
So what happened? Why not say? And
Because
MP?
someone else answered.
MP?
Bhopal.
Okay. UP?
Lucknow,
Karnataka?
Bangalore.
Bangalore,
And Tamil Nadu? Tamil Nadu?
Chennai.
So this is the set A, this is set B. When I say A cross B, then you have to take every element of A and you have to create a ordered pair. So you have to write like this. MH will go with, this is too much. So we have 1, 2, 3, 4, 5 and 5, 25 pairs. So that's too much. So I'll make it 3 because I cannot keep on writing those number of terms. So I'll just keep it 3. Rest I will delete. Yes, take a lot of time. So Cartesian product is like if the first set will have 3 elements, second is having 3 elements, the total number of Cartesian product will be 9. 3 into 3, 9. And how we write? So you take every pair and you keep on multiplying. So you can write as MH comma MUM comma, you can write MH comma BP. Let's make it simple. Then MH comma LK. Just I'm making it shorter. Then again we'll get 3 more for MP comma MM. Let's remember MB, and then MP comma BP, then MP comma LK. Then we have 3 more UP comma Mumbai, then UP comma BP, and UP comma LK. So in the Cartesian product, how many set we are getting? How many like pair we are getting? So we are getting 9 pair, and this 9 pair creates another set. So the number of the number of elements in a Cartesian product is simply product of numbers in every set. Okay, so these are the 9 pair of set. Now we'll talk about something called relation. So relation is something like, you have some sort of and the word itself is a meaning. The relationship means some well-defined relationship we are trying to figure it out. So when we have Cartesian product of 2 set, then every pair cannot be meaningful to us. Okay. So based on the definition, some of the ordered pair may be meaningful, and some of the ordered pair may be meaningless. So relation is all about finding the meaningful Cartesian product of a 2 set. So let's say if I want to relate the set A with set B under some definition, which I will decide. So let's say I'm trying to understand what is the state capital relation. So if I want to understand the state capital relation, then out of these 9 pairs, how many pairs are meaningful? So out of 9 pairs, you can see only 3 pairs are meaningful, the rest are meaningless. So relation is always a smaller version, a lesser version, or maybe it may be equal to version also, which I don't know. In some condition, it may be equal, but right now I can see it's less than. So the number of element in a relation is always less than or equals to the Cartesian product, or you can say relation is always a subset of Cartesian product of 2 set. But in set theory, we don't use the less than symbol. So how we write the same? So we write something like this. This is basically less than equals to symbol. So we say that R is a subset or a smaller version. Subset means possibly smaller or equals to version of the Cartesian set. I'm not sure about the equality. I'm not sure about it is going to be 100% less than also. So that's why we write less than or equals to symbol. Okay. So this is called subset. But if you remove the equality, then this is called the proper subset. Proper means it is definitely less. And this way of writing is called only subset. Understood? So one is the subset, other is the proper subset. So what is relation? So relation is always determined based on the Cartesian product of 2 set. So when we have the Cartesian product of 2 set, then the meaningful pairs based on the definition, is called the relation. That's the meaning of relation. So let's say if I want to find some other sort of relation, like Here the definition was state and capital, and these three underlined pair was the meaningful pair. Rest was meaningless. So, what are the other possibility that we can create? Okay. What are the other possibilities that we can create here? Let's say I want to relate something like, let me see if I can get something. So which pair share the border? So now my relation is which pair share the border? So of course Maharashtra, I mean share the border means if it either it is part of the state or it is at least sharing the border. That's the meaning of it. Let's say if I create a new definition, like which pair, but this is meaningless. In this case, it's meaningless. I need to take some other example. Now, what I'm trying to say is that okay, in case of Cartesian product, every definition that you will impose will give you a different pair of values. So, one relation is always something that we define, and based on that definition, we get some output. So, Cartesian product is a generic thing, and relation is the condition imposed on the Cartesian product. So that is how we bring out the relation. And the next stage of a relation is called function. In short, this is the whole idea. So the only difference between the relation and the function is also relation. Okay, every function is a relation, but every relation is not a function. What does it mean? Can you explain? Every function is a relation, but every relation is not a function. Who can explain? I think Kanu can explain. So what is the basic difference between the function and relation? I hope you have studied the basic of calculus. Anything which comes to your mind, you can say. Hello, hello. Am I audible, guys?
Yes, sir.
So tell me, Ganesh, you know something about this relation and function?
Yes. Sir. Function is basically a relation for which there's a unique input output kind of a relationship.
Yes.
Like,
Correct. So it is basically a mathematical relation called function. So relation can be mathematical also and non-mathematical also. But when we say function, then we actually talk about the mathematical relation. That's the only difference, nothing much. So relation is just a relation, which is also possible between the non-mathematical entities. But when we say function, then we only refer to the mathematical entities. Okay. So let's say 30° is a some value, it's the angle, but sine of 30 is what? 1/2. So what sine is doing here? So there are many ways you can think it. Sine is like a function which, I mean, or you can say operator which when operates on the input called 30°, it gives you output called 1/2. There are many ways. So when we deal with the mathematical relation, we call it function or mapping. Okay. So let me put this way. It is a relationship between two set. So it is a mathematical answer. It is a mathematical relationship between two sets that's it. So mathematical relationship, it is always well defined. It means you can express things. So for representing the relationship between two sets, let's say we have two set A and B. We introduce the concept of variables. So there are two types of variable that we introduce. One we call X, another we call Y. So in mathematics or in physics or everywhere else, we have two types of variables, and we'll keep it to variable like one because we are learning the calculus in one variable, so we'll not have multiple variables. So we'll just keep X and Y. So there are two types of variable. One is called independent variable, and the other is called dependent variable. So generally the independent variable we always graphically we show on a x-axis. I'm not saying it is called X, it is put on the x-axis. So generally, I mean, it's like a convention, and there's a very famous phrase that convention after a long time becomes rule. So it is a convention and it is being followed for such a long time that now it is like a de facto rule. So independent variable we show on the x-axis. In mathematics, in fact, we represent by x most of the time. Again, it is not a condition that you can only take x as independent. You can choose any y as independent. I cannot stop it. It's like convention. And dependent we show on the y-axis. And if there is some relation which connects the two, so we represent by, you can draw some arrow. So I should have taken x here. And then we said, because these are related with a function f. F is some mathematical relation which I right now I don't know what is that relation. So let's call it function f. So we write as a symbol f. And because y is a dependent, a dependent variable on x, so Leibniz introduced the notations. There is called Leibniz notation. So Gottlieb Leibniz is the name, I think. So he introduced the notation that y is a dependent variable. It depends on x by some method or some relation. So we call y equals to f of x, function of x. It is not product. I'm just writing, it is like a way of writing. It's communication actually. So what we call y is a function of x. That is how we write. So the dependent we write on the left side, and by writing equals to, we write the independent variable under the parenthesis prefixed by the f symbol, and that is only to say that okay, y depends on x by some relation which I don't know what is that relation. Once I give the definition, you can say okay, that is the relation. So y equals to fx is a just notational value. I mean, there is no meaning to, there is no calculation I'm doing here. It's a notation. So for example, if I write y equals to x square, which means for every number x, the y will be square of its value. So if I draw something number, let's say 1, 2, 3, 4, 1, 4, 9, 16. You can clearly see the relation, isn't it? So what you can see the relation? That x equals to 1 will be y equals to 1. 2 will be 4, 3, 9, 4, 16. So 1, 2, 3, 4 are the independent variable. And because y is the square of that number, so in the set of y, what we get is 1, 4, 9, 16. So this is a discrete set. If you take a set of x is belongs to a set 1, 2, 3, 4, and then y belongs to 1, 4, 9, 16. Possibly we can say that both are related by a function, but this function is actually x square. That is the name of the function. Now we know. Earlier I was not knowing what is f of x. Now we know is it is x square. So when you say y equals to x square, then you also know that f of x is both are same way of writing. Either you write y equals to x square, or you say y depends on x by the relation which is gained by mathematically x square. So that is some notational value, and these are some convention that you need to follow. In mathematics, we have mostly continuous functions. We don't have the discrete functions. But in continuous function, we have some sort of some missing pair, some missing values. So we call it discontinuity. Like out of a large set of values, some values are missing. So we have discontinuity also. We have entire chapter based on that called the limits, continuity, and differentiability. So all are related to each other in one way or the other. Okay. So I hope the function is not very difficult to understand. What is function? A way to say the relationship. There are many notational way of writing. So we write f is a relation such that from x to y. And sometimes you also write f is a function which relates real to real, which means it is a relationship between two real set. That's the meaning of this. So R to R means f is a relationship between two sets. Both set belongs to real number. That's meaning R to R. Or you can say f is a set, f is a function or relation between two set from R to R plus. It means the first set will have any number, positive or negative, but the second set must be having positive number. So you can also understand, okay, if the first set is x, the second must be x to the power how much? If I call this as x, this must be x power any even number, right? Or any, you can say modulus or power even number. So anything like this must be there. These are the ideas of writing, and it's a literature. Actually, if you want to master calculus, you need to read literature, like how these symbols are read actually. Because most of the difficulty which I have observed among students, they fail to read these mathematical symbols. Like they don't understand what they're trying to convey the message. If once you understand the message, it's very easy. So these are like literature. It's just a pure piece of literature, nothing to do with mathematics. Mathematics is writing your ideas into some notational, like some symbolic literature. Now, to master mathematics, one has to understand the meaning of the symbol. Okay, so while learning maths, try to develop those literature value. Don't solve as a question and answer. Take the literature meaning and read some theory about function. There are many books of function, exclusive theory books of function. Okay, so with time you can read and understand. Now, don't read now. Take some time. Maybe after 1 year, you start reading the function. You will understand better when you have some sort of ideas about maths. Okay, so every mathematical relationship we call function, but there are mathematical relationship which we don't call function, and I'll come to that in a different manner. So let me tell you some condition on dependent on independent variables. So let's say So let's say this is your home. And this is your school. The school is dangerous, so I'm putting a red symbol. Okay. And this is the connecting road. So I'll take the beginning as origin, and I'll call this as x-axis. And as you walk, there are some distance that you can measure. So let's say when you leave the home, let's call that as t equals to 0. So let's call time is one variable, and the distance from the home that you travel is another variable. So time and distance are two variables. Okay. Now, what will happen? As time will progress, you may walk further. So let's say at t equals to 0, the distance from your home is 0, because that is how we started the measurement. Okay. The total distance from your home to school is, let's say, 10 kilometers. Okay. So you start from your home. After, let's say, 10 minutes, you have almost traveled 2 kilometers. And in between, then another home comes, which is your friend's home. So you thought of meeting your friend and going together, because you have a car. So you thought of giving a lift. So you stop after 2 kilometers, and then you wait for your friend to come down, and then you will go together. In the meantime, you spend almost 10 minutes there. So at 20 minutes, what is your distance? It is still 2 kilometers, isn't it? Hello, hello.
Yes, sir.
So you have spent 10 minutes, but the distance is still 2 kilometers. Then finally, your friend comes down, and then you start moving again further. So in the next, let's say, 10 minutes, which is now 30 minutes now, since beginning, you travel another 3 kilometers, and then now you have 5 kilometers away. Then in the next 10 more minutes, when it is 40 minutes, because you think, okay, you're getting late, so you drive in faster, then you travel 4 more kilometers, and you reach 9 kilometers. Now you should know that, okay, time is still left, and now there is no traffic, just 1 kilometer left. So you take a break, and you go and take some snacks. Okay, maybe some street side food which you like. So you stop there just before your school, and you buy something, because you know there is enough time, and you spend 5 minutes. Your distance is still 9 kilometers, and then finally in the next 2 minutes you reach your school. So if I want to draw the relation at 0, it is 0. At 10, what is the distance? If you remember, at 20, if you remember, it was still 2. At 30, how much? 5. At 40, 9. At 45, and at 47. Okay. So you can see that many independent variable. Okay, now first of all, which of the two is independent variable? Time or distance?
Time.
So time is the universal independent variable. We cannot stop it. So time is the independent variable. It will keep on moving forward. Okay. And distance will depend on, like, of course, for every distance we must have some time, right? Isn't it? So to travel from there to your home to your school, you can see these are relationship. If I draw the arrows, now you can see that there are many values of x having same value of y. But the vice versa is not possible. So this is called many to one relation. So many time will have same x, same distance. But is it possible to have same distance at multiple time? At one time, can it be have multiple distance? Is it possible that at some time you are at 4 places? Is it possible?
No.
So mathematically, when we talk about function, then there is a condition on independent variable and dependent variable, and the condition is whenever there is a relation between time and distance, we cannot have multiple dependent variable and single independent variable. Is it not possible? We cannot have multiple distance and one time. Okay. What is the meaning of this? In mathematics, when you study something called graph, or when every mathematical function we can represent as a graph. So for one x, we must have how many y? For one x, how many y is possible? At 10 minutes, what is the value of y?
2 kilometer.
So at one x, we have only one y, na? Or we have multiple y. Can you see? So for every single independent variable, the only possibility is we must have only one dependent variable. For every x, we must have only one y. For multiple x, we can have multiple y, but for one x, we must have one y. So let's say if I draw a circle here, if I draw a circle, and we know the formula is x minus alpha whole square plus y minus beta whole square equals to some a square. Can we call such relation as function? Yes or no? If you look carefully, for one x, we can have multiple values of y possible. You can see the same x can have this y, the same x can have this y also, which is against the rule of function. So this is of course a mathematical expression, but this is not a function. In function, one value of x cannot entail multiple values of y. So this is called the vertical line test. So to understand whether the given graph is representing a function or not, the simple rule is you draw a vertical line, and if it is intersecting the graph at multiple points, it is not a function. So this is not a function. Actually, if you look in detail or carefully, it is actually two functions written at once. How? So I can write y minus beta whole square equals to a square minus x minus alpha whole square. So y minus beta is plus or minus of this root, right? So basically this is two function. If I write only plus, then one function. If I write only minus, then one function. But this way of writing is writing two functions together. So therefore it is not a function. It's a different way of writing multiple function together. And therefore this is simply the vertical line test will give you the idea whether given graph represents a function or not. The rule is simple. One independent variable must give you one dependent variable. If it is more than one, it means it is not function. Just a minute. Okay, so if I have a graph like velocity and time graph, which will come across quite often in kinematics, and you can see the convention. I always plot the time on the x-axis because that's convention, that the independent variable should be put on the x-axis, dependent on the y-axis. So is this graph possible? Can we have a velocity and time relation like this?
No, sir.
It is ridiculous. It's not possible, right? Because if you look carefully, if you draw a vertical line, at one time you have three velocities, which is totally meaningless. So if you're driving a car, at every instant your car will have one speed or multiple speed.
Only
if
one
you're
speed.
Yeah, you must have, at one time the car will have only one speed. Okay, is it possible to have same speed at every time?
Yes, sir, it is possible.
Yeah, that is possible. So this is not a function. So this relation, this velocity time graph is not possible. Because if something is not possible, it means such relationships are not possible. And if such relationships are not possible, it means this is not the velocity time graph. Okay. So every mathematical equation is not function. That is what you need to understand. But if I draw something like this, now this is velocity and time graph. Is this graph possible? Is this possible?
Yes, sir.
So this is possible. So such relationship or such graph we are going to see in future also. So these are some basic questions from your NCERT. If you have the NCERT textbook, you can open the first chapter of kinematics. You will see such graph given, and they will ask you which of the following graph is possible or not possible. You can answer it very easily. Is this graph possible? Is this possible graph? Yes or no?
Yes.
So it is definitely possible that what is happening at every instant we have only one velocity, right? And you can say luckily or fortunately or unfortunately, all values are same. So this kind of graph represents what? Anyone? What we call?
The uniform box.
Uniform velocity. Very good. Let's call uniform motion. Okay. So this is pretty simple. This kind of thing always represents the uniform. Okay. And if I draw something like this, so this kind of graph is called exponential graph. So you can see it is very slow in the beginning, but suddenly it goes very high. So I think same thing happens with when the flight takes off. The acceleration in the flight is kind of exponential. It suddenly generates so much thrust that it runs off the runway. Okay. So there is again the input output model of a function. So if we have some sort of imaginary box in which if we have some function, then if you give x inside, it will do something and will give you the output on the other side. Okay. And then you can keep on writing multiple function. So this will be the first output, you can say fx. And then if I bring another function which operates on its input, so now the input itself is fx. So what will get output? So what will the output? See, x represents input. It is not x symbol. It is input value. So whatever is the input, that it will operate and will give you the output. So what is the output here? Let's call y dash. So G will operate on which input? Can you see the input? What is the input for this box? The output of the first function is the input of the second function. So we write a G of like this. The input itself is fx, correct? So when we write like this, we call it a composite function. It's a function of function. We call it composite function. And there is a way of writing this. We write as GOF. It's another way of writing GOF. GOF means, see, on the right side, whatever comes is the input value, and the left is the output value. So if I write something like f of g of h of w of u of v of x. I don't know how many bracket I need. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So can you tell me what is the first function? The first input was, can you guess? The first input was
Right.
x.
Yeah, sorry.
X is always the first input, right?
Mhm.
And then what is the next input?
V.
P of x.
V of x. Very good. And what is the next input?
U of v of x.
U of v of x. Whatever. What is the next input then? W of something. Then the next input will be the h of something, and the next input will be let me change the color. So this is like, you can create something like composite function. Now, of course, composite function, when we create, we have to take care of a lot of things that's called the domain concept, because every function is not defined everywhere. So of course, if you're making some sort of chutney using the coriander leaves and some tomato, ginger, garlic. So when you make this chutney, then of course you mix all these things together and then you put on something else. So maybe the first preparation, you make the puree as a first input, you put on the another mixture in which we have the garlic and ginger. You get another thing, then you put in a frying pan, you create some recipe actually. Now, of course, they all belongs to the domain called food. Okay, you can say food is a domain, or we can eat at least. Now, we are not going to put that into, let's say, in creating some other thing which is not at all related to the food. Okay, so I cannot take the chutney and put in, let's say, a Fevicol jar and try to fix two ply together. So there's a constraint on domain under which we can do this composition. So the rule says that composition is only possible if the domain of the inner function must be the subset of domain of the outer function. It means the inner function should be actually smaller. in its scope actually, or at least equal to the scope of the outer function. And if it belongs to, so let's say if this is the outermost function, okay, you can easily understand this, then every function should be, if this is the outermost, then every inner function should be within itself. It can be equal, that's okay, but it cannot be more than that. So every inner function must have the domain. So this is called the domain condition. So when you create a composite function, the rule is the scope should not exceed. If it is exceeding, it means such composite function cannot be created. Understood? So again, those are rules which we'll study in mathematics. The domain of composite function. So every inner function should have the smaller domain, or you can say if you create function, then the domain will be, every composite function will have now a curtailed domain. Let's say if I create a function, so let's say the inner function is this much. If this is the domain of the inner function, and if this is the domain of the outer function, somehow, let's say this is the case, this is the scenario, then what will be the domain of the composite function? The bigger or the smaller? So you can say it is the intersection, right? So the domain of the composite function, now I have to create a new domain in which that function will be defined, and beyond that it will not be defined. So this small portion, which is common to both, will become the new domain of the entire system. So in a way, composition affects the domain actually in which it is going to work. So if it is subset, then it will work for every values of variable. If it is the reverse, if the outer function is subset of the domain of inner function, in such scenario, the domain will get modified. Okay, so it means the domain will reduce or will change, and you have to be very careful when we talk about the composite function and the effect on its domain. Okay, of course, these things are job of the math teacher, and I will not interfere in that. You can study about it. So these ideas you just need to have. We'll solve some of the question. So let's say if I say f of x is 1 upon 1 plus x square. So if I ask what is f of 1, which means if the dependency on x is by this relation, now this on the right is called relation, the exact relation. Okay. So when x is the input, then output is 1 upon 1 plus x square. So what will happen if the input becomes 1? What will get? If the input is 1, then what will get on the right side?
1 by 2.
So if I write 2, then what is the output then?
1 by 5.
Very good. So if 1 by x is the input, then what will get? If the input itself is 1 by x. See, think as input, don't think as a maths.
X square by x plus 1.
X square by x square plus 1, right?
Yes.
So it is 1 upon 1 plus 1 by x whole square, right? And this will become x square by. So if I give the input as x upon x plus 1, then what will the output? 1 upon 1 plus. Okay, so you have to just keep on substituting the input in place of the original input. So you have to read this x as input, don't read it as variable. If you read as input, it's easy. So f of input is 1 upon 1 plus input square. How to read? F of input is equals to 1 upon 1 plus input square. That's it. Whatever you give me input, I'll convert in this format. That's the meaning of it. So if I say f of x as x square plus 1, and if I say g of x is 1 by x. So if I ask you what is the fog of x, fog means f of gx, and what is golf of x? G of x. Tell me the answer. It's very easy, I think. So what is f of input? Input square plus 1. What is g of input? 1 upon input. Okay. Hello guys.
Yes, sir.
Inaudible. Tell me the answer. What is fog of x?
Sir, x square upon x square plus 1.
X square.
Square upon x square plus 1.
I think we're saying reverse. So
So
f
1
of
upon x
yeah.
square plus 1.
Yeah, 1 upon x square plus 1, which is like x square plus 1 by x square, right? Like this.
Yes, sir.
F of gx, input is gx now. Whatever gx gives, that is input. So you substitute first here 1 by x, and then what you get the input, you substitute the input here. So see how to read. F of input is square plus 1. G of input is 1 upon input. It's not difficult. So what is the g of fx? Tell me. So it will become 1 upon input, which is f of x. G of input is 1 upon input, so we can write like this. And f of input is input square plus 1. So you can convert like this. Think this way. Is it difficult? So if I say another example, f of x is e power x and g of x is sine x. So what is the value of f of gx and g of fx? Tell me.
F of gx is e to the power sin x.
Yeah, that's correct. And this will be
This will be sine of e to the power x.
simple. Anyone having difficulty in understanding this? I don't think it's very difficult to understand.
Sir, for the previous example, for the
Mhm.
g of x, sir, why have
Of-
you written 1 upon f of x?
See, this is the input. For
Yes.
G, this is the input. So G
Yes.
of input is 1 by input. So I can write this as G by input equals to 1 upon input, correct? And
But
then,
there, the f of x you can substitute by x square plus 1.
yeah, so then I can substitute here. It's a reverse, like you can do in any order. It doesn't matter.
Okay.
You can do in any order. So you can keep on writing like this till you get the simplified version. Okay.
Yes.
Any doubt again? Tell me. I think these are not difficult thing. I mean, just it's a literature. We have to read the way it is written. So f of something, g of something, these are just symbols. So see, in physics, the function will not come the way you see here. So let's say if I write velocity equals to 2t minus 5t square plus 5 meter per second, where t is in, of course, seconds. So if you look carefully, velocity is the which kind of variable? Dependent or independent? Tell me guys, v is what kind of variable?
Dependent.
Dependent. Very good. And t will be here
Independent.
independent variable. So one is dependent, other is independent. So is it a function? Is it a function? Or is there any relationship between V and T? The answer is yes, because I'm writing equal. Equal means I'm writing the relation directly, right? So here you can say velocity is a function of time t. And what is that function given to you? 2t minus 5t square plus 5. So when t is the input and ft is the output. So if I want to know the velocity when t is 1 second, what will be the answer? When t is 1 second.
2.
So it is 2 meter per second. If I want to know the velocity at t equals to 0, like I want to know the initial velocity, that's called initial velocity. So to know the initial, what we do? We put t equals to 0, that's called initial. So in kinematics, the word initial basically refers to when time is 0. So when time is 0, what is the answer? Tell me, guys.
5
5.
meter per second.
5.
So they will never give you the initial and final. So this is the function given to you. So initial you can always determine just by substituting t equals to 0. And luckily here it is 5. And what you can see at t it is 5, but at t equals to 1 it is 2. So this is definitely the question of accelerating body or a retarding body.
Returning.
Everyone please tell me. Is it a case of accelerating or a retarding object?
Retarding.
It is retarding, definitely. Okay. But let's say if I want to know when the velocity will become 0, when v will be 0, that's question. So what we'll do, we will substitute 0 on the LHS and we will solve the quadratic equation. So I can add 0 equals to 2t minus 5t square plus 5. This is a quadratic. I can rewrite as 5t square minus 2t minus 5 equals to 0. What is t value? You know the quadratic answer, right? Who will tell? Come on, guys, tell me. So t equals to how much? Hello. Can I have some answer, please? No.
-2 plus minus root 104 by -10.
-2. -2. No, no. -2 is not possible. What is the formula of quadratic? Minus b plus minus under root of b square minus 4ac upon 2a. If I still not used to this formula, please get used to it. In physics, you will not get the factorization easily, so you should know the formula directly. So then t we can write as minus b, which is 2, minus or minus 2, right? Plus minus b square, which is 4, 4ac, 2a. So t turns out to be 2 plus minus under root of how much? 104. And minus is not possible because in physics we have to look for the feasibility of the solution. So we can only keep the positive answer. So it is roughly 12 by 1.2 second, right? Then find the exact value using the binomial. So we can write this as 100 plus 4 power 1 by 2. Okay, I'll do this separately. So you can also understand what we learned is of some use. So we want to know this answer. So I can write as 100 plus 4 power 1 by 2. I will take 100 common, so it is 100 power 1 by 2. And then become 1 plus 4 by power 1 by 2. And then I can keep this as 10. And this becomes 1 plus 1 by 2 into 4 by 100. The power gets multiplied here. So 10 into 1 plus 2 by 100, which is 0.02. It is 10.2. You can use calci, you can check the answer if it is coming closer to that. It is quite close, it's 10.198, which is a very nice approximation. And therefore, you can get the answer T equals to 2 plus 10.2 upon 10. It is 12.2 by 10, which is 1.22 seconds. Roughly, we got the time. So at roughly 1.22 second, the particle will come to rest. Understood? So in physics, the function will not come as a function, of course. You have to understand the meaning of it. You have to understand that the dependency, and you have to understand what is dependent and what is independent. Okay. So let's say you're solving the chapter called gaseous state. You might have heard about the ideal gas equation. Okay. In which the pressure and volume, so let's say PV equals to nRT is some sort of equation. So if I write something like this, that pressure of a gas depends on the temperature by relation AT minus BT square. So again, this is the function of, so we call pressure is a function of temperature. That's it. Okay. So pressure is a function of temperature. So it is like how you interpret the idea of maths in physics. I mean, they will not tell you that y equals to fx. You will never see the y equals to fx in physics. You have to search for yourself. And then every temperature will have every one temperature will have one pressure. Okay. Anyway. So yeah, that is simple. That is done. The fog you understood, the golf you understood. Okay. So now we can go to the and towards we can move towards the derivative. So before the derivative, we'll try to understand the concept of change. And to understand the concept of change, we have to understand the concept of limit. The limit has come from the word limiting. Or you can also say limited, something which is limited. So on a number line, if you draw any number line, and if you mark any number, so if we have a number line and if I say this number as A, this is the positive side of the number line, this is the let's say negative side. So in how many ways we can approach A, or we can arrive at A? In how many ways we can come to A? Following the number line, of course, you cannot just come to A in any direction. So we say that we can come to A either from this side or from this side. So there are two possible ways of coming to A, right? Either this way or this way. Now, what are the difference of coming in these two ways? So if you come from the left side, what will happen? If you approach A from the left side, what will happen? Your value will be less than the value of the number itself. Isn't it? Hello, hello, hello. Hello. Am I audible, guys?
Yes, sir.
Please respond. I mean, your response is important. So if A is a number and if you are trying to approach A from the LHS, the left hand side. So if you're trying to approach, see, you haven't arrived at A, you're still approaching, you're coming as close as possible. So when I say limit, it means we have to come to close to that number, but we have to never become that number. Understood? So there is a very famous story, and in which you are supposed to walk. So let's say, can you walk 1 meter? If I ask you, can you walk 1 meter? Anyone who is able to move 1 meter? Tell me, guys, can you walk 1 meter? Yes or no? Okay, no one. Oh my God. So no one is able to walk 1 meter.
So we can walk.
Now I give you a condition. You have to walk only half of the distance and stop, and then again walk half of the next distance. So can you walk 1 meter now?
No, sir, we can.
So mathematically, of course, you will never walk 1 meter. But in reality, eventually you will walk. So see, mathematics is deceptive. So first you will walk 1/2 meter. Then how much you have to walk next time?
1/4.
And the next time? So will it ever end, or it will come up to infinity? Correct?
Yes.
Because see, you have to only walk half of the remaining. So mathematically, for every number, there is half of that number always available. But luckily, in mathematics, there are two types of summation. One is called the two types of series actually we call converging and diverging. Converging means although you add infinite values, but eventually it gives you finite answer. So you add infinite terms actually. So even the infinite terms will add up to something finite. And it is also possible that the summation of infinite terms will actually make it infinite. So something can explode also. Okay. So we have something called converging and diverging series in mathematics. So this is basically a infinite GP actually, the geometric progression. And because this is the infinite GP, so infinite GP is always converging. It gives finite answer. So again, okay, I wanted to say this. If we have the infinite GP, so let's say what is the sum of GP? I think nowadays this is taught in class 10th also, right? So the sum of infinite GP is the first term upon 1 minus common ratio. R is called common ratio, which is the ratio of the second by first, third by second, fourth by third, and so on. So if you divide the next term with its immediate term before, where what we call is called the common ratio, and if we have number in which the common ratio is constant, that represents the geometric progression, and if you add infinite such terms, then we write as a upon 1 minus r, but this is only true when the r is less than 1. So when the common ratio is a fraction, okay, when the mod of this is fraction, then in such case, the formula will reduce to this nature. And this is what we are going to use a lot in physics also. And we also have the arithmetic progression, in which we have the number like a plus d. The next will be a plus 2d. The next will be a plus. And what is d called? D is called common difference. So in any arithmetic progression or arithmetic series, what is the sum of value? The number of terms by 2 into 2a plus n minus 1 into d. Or you can write as, if you don't know this, n by 2, first term and the last term. That's it. So if it is arithmetic series, then the first term, the last term by 2 into n will give you the total sum of the values. Anyway, this is not required. So we are talking about the limit. Limit means every number. Let's take a number 1. Or let's take a number 0. Now 0 is a very special number because if you approach 0 from the left side, so let's say a number is as good as 0 but not 0. So it is, can you tell me the number which is as good as 0 but not 0? So you can say 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000and then you put 1 if you're tired. Even that number is much bigger. So again continue the same. So then you put 1. So that number is called a number close to 0. But there is another number which is also close to 0, which is minus 0.0000000000. That is also close to 0. The only difference is the way you approach the number. If you approach from the left hand side, then the number will be as good as 0, slightly less than 0. Okay. So any number x approaching 0, so we say limit x tending to 0. Now, because there are two ways to approach any number on a number line, left and the right. So to approach from the left side, we write O minus. So it means we are approaching O from the negative side of the number line. So this way of writing is called left hand limit. Left hand limit. But if I write, what does it mean? We are approaching 0 from which direction? From the positive direction of the number line. So what we call this as? Right hand limit. Understood? And x tends to 0 is not equal to 0. Because when I say tends to something, then I am as good as something, but I'm not equal to something. Are you guys getting this idea? What I'm saying? Hello,
Yes.
hello. Yes or no?
Yes.
Anyone not getting it? I mean, I will explain again, not an issue. Anybody not getting this? So every number can be approached in two ways, left side or right side. And there is again, see, math is all about notation. For everything, they have a notation. That is the problem, that you get so many notation, you get confused. But once you understand the meaning, it's very simple. So when I say x arrow 0, it means I am approaching 0. So I am someone which is as good as 0, but I am not 0. Okay. So what is the difference between a number tending to 0 minus the number itself? Minus 0. X tending to 0 minus 0. What is the value of this? Is it 0 or non-zero?
Non-zero.
It is always non-zero. And this number, later on we'll study, this number in mass is called epsilon. So epsilon is the difference between the two numbers. So this epsilon was very old mathematical way to deal with such things. It is still in use. So the difference of a number which is as good as zero with zero is non-zero. And it is always positive. We take always this as positive number. So the concept of limit says that there must exist some epsilon, which is a positive number, such that the zero can be written as, I mean, not zero. The x tends to zero can be written as 0 plus minus epsilon. All are like same thing. I mean, you can understand what I am trying to say. So x tends to 0 is, so similarly I can say x tends to a is always a plus minus epsilon. It is slightly more or slightly less than a, but it is not a. And epsilon is the smallest positive value, and nothing can be less than that. So there is another condition that epsilon is the smallest positive value. Now, epsilon is a symbolic philosophy. It means it is ridiculous to say, okay, so epsilon is the, if you take a difference of x tends to 0 and 0, you will not get zero for sure. But what you will get is the smallest number. It means nothing can come before that also. Can we really express? So what is the number next to 0 or just before 0? Can we express mathematically, or can we write it on a paper? So can we really write the difference? Hello, hello.
No, sir.
See, it is only these are all philosophical gamut. I mean, this is called mathematical philosophy. You have to only understand the beauty of it. It is like I'm asking, have you seen God? You say no. If I ask you, is there any God? You cannot say no. And also you cannot say yes. It is like don't say, because you cannot prove it. But we know that, okay, whether we are able to prove or not, there is a God. These all are philosophical stuff. In mathematics, the calculus is actually entirely philosophical. So what I'm trying to say that a limiting value is not the value, but it is as good as the value. Okay. And that is the whole meaning of limit. And every number on a number line can be approached in two ways. One from the negative x-axis, a negative number line, another from the positive direction of number line. And therefore, you can get a difference which may be positive, which may be negative. The modulus is always positive, but the difference may be positive, may be negative. We cannot say. And the modulus, the difference, the modulus we write by a symbol called epsilon. Okay. Later on, Newton said the same epsilon in a different way. So what he said, that anything, if you have x, I mean, of course, it's even deeper than this, but you can take this as a rough analogy. I will not go into detail of mathematical axioms. So Newton said that if you are at any location, let's say if this is the x-axis, then this is representing some x, which I don't know. If this point is representing some x, what is the next point that we can represent? And if we want to represent the next point, the point next to x, what is he trying to explain? The limiting value, right? If I ask you which point comes after x, if I ask you which point comes after x, so you will say it must be x plus e. by definition. Now, of course, we don't know what is that. So we will say the next number x to number next to x will be x plus epsilon, because that is the smallest gap that we have taken symbolically between two numbers which are very close to each other but not equal. Newton replaced the epsilon and he said that the number next to this number is x plus dx. That's it. That was the way of writing for Newton. But in case of Newton, the dx can be negative also, dx can be positive also. So he introduced a elementary concept. So this kind of change, when two numbers are as good as same, but they are not exactly same, such change is called, or such difference is called elementary change. So this is called elementary change. A change in which, so technically we cannot represent, but we do represent for the illustration. It is only philosophy. I mean, can we really show something on a number line like this? The answer is no, we cannot show something like this. Because they are same number. They are x only. Just they're not x. Almost same, but not exactly same. So one is tending to x, other is x, exactly x. And when we are in a situation when one is tending to a number, other is exact number, there is a gap between those two numbers, and mathematically we have found some literature or symbol or notation to express it. So these are ways to express the emotion. So Newton found that ways of representing the emotion. Okay. I hope this part is okay. I mean, you understand the meaning of limit? It's very simple. Limit means not the exact value, but it is a value which is slightly different from that value. So there is a very interesting fact that if I say 1 upon x tending to 0, now this is meaningless because x tending to 0, there are two possibilities. So I can approach from right side, or I can approach from left side. Can you tell me the value of both cases? If one is divided by a number which is very, very small as 0, but not 0, what will get the answer? A very, very large number, isn't it?
Yes.
So 1 upon a number which is very small, inverse of very small will become very large. Yes or no?
Yes, sir.
So if you approach from positive side, then the 0 minus this number will be, or this number minus 0 will be how much? This number minus 0 will be positive or negative.
Positive.
Positive.
So this will give you a number more than 0 or less than 0.
More than 0.
So this will become tending to positive infinity. How many of you are able to understand this part? That if x is approaching 0 from the positive direction, then the ratio, the inverse will approach positive infinity value. Are you guys able to understand this part?
Yes.
But if I write 1 upon x tends to 0 minus, what does it mean? We are coming from the left side. So this number is less than 0, right? This is not 0. This is less than 0. So it is a negative number, right? Although very small, but it is negative. So 1 upon something negative, which is very small, will be how much?
Minus
This
infinity.
entire number will approach minus infinity. Understood? But if I write 1 upon 0, what does it mean? It means there is no number below actually. So this is called undefined. I mean, I'm not dividing. It's like 1 upon nothing, vacuum. So 1 upon 0 is undefined. So such mathematical expression must be avoided. This is defined. This is defined. But this is undefined. We cannot make any mathematical sense of division by nothing. So that's why 1 upon 0 is called one defined state. So mathematics will have no place. And because 1 upon 0 is undefined, so in fact anything upon 0 is undefined. So these are called undefined state. So if I ask you what is the difference of 2 infinite? Infinity is like, we don't know how big is that. The other infinity can be compared to infinites. The answer is no, we cannot compare infinite. Understood? So this is again called the undefined state in mathematics. So 0 by 0, infinity minus infinity, then 0 power infinity, these all are undefined state. Because if there is nothing, then mathematically we cannot put something on nothing. Right? What is this? Power to nothing. I don't know what it is. So we call it undefined state. So we deal with mathematics only for the defined state. We never deal with the undefined state. Understood? So there are actually 7 such undefined state. So in mathematics, there are many things which are undefined. So you can also write plus minus. I think plus is plus, minus. So we have many undefined state. These are very famous ones. So any mathematical expression which is in the undefined state cannot be analyzed further. So the mathematical analysis is only possible when they come into the defined state. And then we can progress by writing something more. So solving the question of limit is basically a transition from the undefined state to the defined state. So if I ask you that x square minus 4 upon x minus 2, limit x tends to 2. Tell me, is it defined or undefined state? For 2, for if I assume x equals 2, then which state it will go to? So if you put exact 2, the problem is, if you put exact 2, the numerator will be 0 and the denominator will be also 0. So nothing upon nothing, it's a which state?
Undefined.
It is
Undefined.
undefined state. So we cannot put x equals to 2, which is because x is as good as 2. So actually we have to put x equals to 2 in the answer. But this is the right now, this is the state in which it is undefined. So we cannot put it. So before we put something, we have to convert it into a defined state. So what we do? We can attach x minus 2 into x plus 2 upon x minus 2. Now when x is tending to 2, so x minus 2 will be 0 non-zero. This term is 0 non-zero.
Non-zero.
So two non-zero object, which means two something can be cancelled, like something upon something we can cancel, right? Something upon something we can cancel, yes or no?
Yes.
And once you cancel, we left with only this much. Now, whatever you put here, is it defined state or undefined state? This is perfectly defined state, correct? So now I can put 2. So this is roughly how much? Because x is almost 2. So almost 2 plus 2 is how much? Almost 4, isn't it? So if I ask you the limiting value, we just add equal to 4. So limiting value, how to calculate something limiting? We have to substitute x value, what you are approaching in the function, by converting that function into defined state from the undefined state. If it, as long as it is in the undefined state, we are not supposed to put any answer. Understood? So that is the meaning of limit. So if I write x power n minus a power n upon x minus a, limit x tends to a. Can we put a right now? Can we put?
No.
We cannot put right now. Because if you put right now, what will happen? It will go into the undefined state. Okay. So right now we are not eligible to put x equals to a in the formula. We have to eventually put, but not now. So what we'll do next? We use some approximation, some relation which we know. So I have taught you what is a power n minus b power n. We can write this always as x minus a into, if you remember the algebraic expression which I gave you. So we can write as x power n minus a power n upon x minus a. We can write x minus a into, we decrease the power of x by n minus 1, right? And then what do we write next? So you decrease the power of a and increase the power of other parts. So we can write x power n minus 1, then x power n minus a power n minus 1. Yes, yeah, that's fine. A plus the last term will be a power n minus 1, right? I hope you remember this part. Whole upon x minus a. Now, can we cancel these two terms? Yes or no? Can we cancel these two terms?
Yes.
Because they are non-zero. So something upon something can be cancelled. Nothing upon nothing. What is that? And now because the remaining term is properly defined, if I substitute x equals to a, what I'll get? Now you can put the value because this is defined a power n minus 1. The next term will be a power n minus 1. And the last term is also. And this will occur how many times? Can you count? How many times we will have to write? See, whenever you forget something in mathematics, take a small power and try to recall the answer. What is a cube minus b cube? Do you remember? A minus b into a square plus ab plus b square, right? So how many terms we get? 3, no? So when power is 3, the answer is 3. So if n is the power, how many terms will get? Tell me. Hello.
Minus 1.
No, it is if a cube minus b cube is a minus b into a square plus ab plus b square. So how many terms we are in bracket? 3
3.
terms. And what is the power?
3.
So if 3 gives 3 terms, so 4 will give you 4 terms and 5 will give you 5 terms. So if we have n power, then how many such terms will get?
N.
So we get n terms. And therefore, this answer is very famous. It is limit x tends to a n a and this is going to be our first derivative formula in the future. Okay. So it is n a to the power n minus 1. Okay. Hello, guys.
Yes, sir.
Yes.
So let's say if we have, this is very, very famous. There are few famous answers which you should remember, a power x minus 1 upon x limit x tends to 0. What will happen? Any guess? Any guess? Tell me, guys. Of course, it's difficult to guess. Okay, first of all, if I put x equals to 0 right now, what will happen? A power 0 is
1.
1. 1 minus 1 is 0. So 0 upon 0 is which state?
Undefined.
Undefined state. So what we have to do now? We have to convert it into some defined state, right? And right now, by looking at it, I hope you are not getting any clue how to do it. Anyone getting the clue? How to do this?
E raised to x minus 1 raised to x.
Yeah, e raised to e raised to
E raised to x minus 1 raised to x.
yeah. So we know that every number can be written as. So we can write. Okay, first I'll write like a power x minus 1 by x. And whenever you get some form, so these are like some very standard answer which you. So a we can write as a e power ln a. And this we can further write as, oh, see, in exponential, the power gets multiplied, right? So we can write as x ln a. But the e power something, but we have x here. So we do some manipulation. What we do is we multiply with ln a here and here. And once you do this, it is matching the format. And what I can do further is you can write as limit. And to match every the format, I will multiply x ln a. But if you multiply x ln a on both sides of the this expression, if you multiply ln a both sides, the right will be still 0. And if I take x ln a as a new variable x dash, then this will look like limit x dash tends to 0 e power x dash minus 1 upon x dash into ln a. And if you remember, this was how much? If you remember, this entire term was equals to how much?
1.
1. And now we can say that limit x tends to 0 a power x minus 1 upon x is equals to ln a. Very interesting. So this we can convert into like this. Okay, ln a. It is clear. So this all formula why I'm giving you, it's my intention actually, because this formula we have to use in deriving the differentiation results. So these 2-3 are very famous. The rest are maybe easy. Remember this 2 formula. So limit is a very simple chapter. What we do is we simply convert something into the defined state, and eventually we put the limiting value which you are trying to put or trying to calculate. So let's say if I ask you what is the limit. Now this is again very famous. I have given this already. So if the angle of a trigonometric function is tending to 0, do you remember this relation? This was equals to, when x is very small, of course it's not 0, it is something. That's a good thing. So x tending to 0 is something, it's not nothing. So sine of something upon something when something is very small is equals to how much? 1. Which means in the limiting case, when angle of a sine function is very small, it is a good idea to just add the number. Okay. So such kind of a relationship, if you understand, it's very easy to solve. So let's see if I write anything like limit x tends to 0, uh, sine square x, or maybe I can say sine cube x minus x square into x. I'm doing some, okay, I need to take the help of some book to give you a question. Just let me see some good questions. Yes. I got the book. Now let me find some question. Yeah, I mean, I got some. So maybe I can say limit x tends to 0, x sin x upon x square. This meaning this x sin x upon let's call it 0, and then okay. So if x tends to 0, this is tan of x square. So what is the answer? This we can solve. Yeah. So x sin x upon 2 tan x square. I'm just making some out of nowhere. So what is the answer here? Tell me, guys. So for a small angle, what you can say? The sine of x will be
Approximately equal to x.
yeah. So it is simply roughly x square by 2x square, because tan of theta is also theta for a small angle, and so it will cancel out. What we get is, even without putting it, because this cancelled completely, so we get half. Okay, let me, if I give you a question, let's say limit x tends to pi by 2, sine of x cos x upon cos of x sin x. I got a book actually, so I'm just giving some random question. I don't know whether it will work or not, but this is the question. That's it. So what do you think? What will be the answer for this? Can we solve this? See, right now I don't know. Think about it.
Result 0.
Cos power 2 is 0, so it is For sure 0. Because 0 point something is no wait. We cannot solve now. If you put now, what will happen? It will become zero by zero only. So right now we cannot put actually. So see here, limit x tends to pi. So x minus pi 2 is tending to 0, right? What we do is we convert this into, I think, sine x into sine of, and this we can write as pi by 2 minus x. Okay. Upon cos of, and again x, and cos of, I'm just trying it, I don't know whether I'll get it. So this will become sine of x cos x, cos of x sin x. And now this is sine of a small angle, and this is tending to, this angle is 0, right? Sine of anything tending to 0 is that angle itself. So we should write x into, can we write this like this at first stage? And cos of 0 is roughly 1. So we can just write as cos x. So I'm getting rid of this. I'm writing this as 1. So this is the part which I got. And then what I'm getting next is anyway, this is coming 0. Now this sine of x into pi by 2 minus x. I can show this will become too much. So pi by 2 minus x is tending to 0. So this is, so again, this we can rewrite as only this much. Sine of a small angle is again a small angle. So pi by 2 into 0, 0. So this we can write like this. So this will become pi x by 2 minus x squared. And cos x we can write as, so this is, we can again cos x we can further write as sine of pi by 2 minus, so this will become again pi by 2 minus x. Yeah, so this is like, or this we can write like this to cancel out. So what we have is x. The pi by 2 should be also. Let me check. Solution. Yeah, that's the right answer. Pi by 2 is the answer given also. Pi by 2. Okay, so what I did, okay, let me tell you the last line which I did. So this I wrote, okay, because see, any sine of any small angle I can write as angle. That's it. So this is what I do. And cos of x is, of course, we can write as sine of pi by 2 minus x, because again pi by 2 minus x is tending to 0. So again, sine of a small angle I can write as angle. And because it is angle upon angle, so now this part gets cancelled. What we are left with is only x. So this will give you x only. And x is, since x is tending to pi by 2, so the answer is pi by 2. Oh, great. So you see, I never read a limit chapter in maths. I always used to solve like this one. I don't know the correct method of solving because I have studied on my own. So, limit question you can solve like this, just common sense. Let me give something easy for you guys. Some good question. I don't know whether it is easy or difficult, but it looks difficult to me. I don't have the easy question. Okay, I'll give you something like this. Limit x square plus 5 upon x square plus 10. And the x is tending to infinity. If x is tending to infinity, then x square will also tending to infinity, right? So if a number itself is infinitely large, so the square will be even larger. So is it finite number or infinite number? So if you right now, if you put infinity, it will become infinity upon infinity, which is undefined state. So whenever you have the undefined state, you can first convert into 0 by 0. Why? How you can take the highest power common. So if you take x square common, what will get? 1 plus 5 by x square upon, you can take x square common. And this is pretty simple for you. Now, if x is tending to infinity, so the inverse will be tending to, tell me guys, if a number is tending to infinity, the inverse will be tending to, hello,
0.
0. And therefore, this term will become 0, this will become 0. Anyway, so the answer is 1. It's simply very simple to remember. It is a coefficient of highest power. So if I give you something like find a limit x tends to infinity, 3x square plus 5x minus 5 upon 4x square minus 6x plus 10. What is the answer? So what we check is the
3 by
highest
4.
power. Yeah. So we check the highest power of numerator and the denominator, and we just write the coefficient of the highest power because everything else will become 0 once we take the highest power common and cancel the effect. So that is how you do limit x tends to infinity. Same thing, 2x plus 5 upon 5x plus 2. What is the answer?
2 by 5.
It's very simple, 2 by 5. Okay. Okay, if I give you the question, let's say limit x tends to infinity. 5. Okay. So 5. Trying to write something like this. Anyway, so you got this idea. So limit, of course, we will study in maths in detail. Don't worry. Some basic formula that you should just know from the limit, the basic manipulation. Maybe this will work. X tends to infinity. question. X power a sine b power x upon sine xc, where a, b, c belongs to real number except 0, exists and has non-zero value. Then there are 4 options given: a equals to a plus c equals to b, b equals to b plus c equals to a, c a plus b equals to c, and d none of this. Think about it. I don't know. See, you can always use the same relation. If something is, if it exists, it means the limit is defined. Okay. If x tends to 0, then all the sine function we can replace by angle only, right? So this you can write easily as, am I audible, guys?
Yes, sir.
So what you can write as x into, let me write once, limit x tends to 0, x sine, what is that? B. For x per a, okay, sine bx upon sine. Oh, no, this was not. X power c. Anyway, for a small angle, what we can write? For any sine question, you can replace by angle. Angle is how much? X power b, right? So what you get is x power a plus b upon c. Now, when this will cancel out or will be defined? When a plus b and c are equal, right? Isn't it?
Yes, sir.
So if if it is exists, it means we can simply say that a plus b is equal to c. And that should be the answer. Please. correct answer. Anyway, so don't worry. I mean, don't think that okay, I'm teaching here limits. I'm just giving you the basic idea that the manipulation is the property that you have to anyway learn on your own. Most of the manipulations can be done with common sense. I mean, I would say that to understand the idea that how to bring something from the undefined state to the defined state is all about learning the limits. It means you can develop the intuition also that how I'm going to bring it from there to here. And if you think or learn that way, you can solve any challenging problem of JEE Advanced almost mentally. At least not I'm saying 100%, but 80% question can be solved mentally just by thinking this particular way. Okay. Okay. I'm done with the all the pages of Zoom is now consumed. So before we end today's lecture, I'll just start something. That if we have a number x, which is the independent variable, and we have something dependent variable called y, which is depending by the simple relation x square. So now I'm looking for the value of y and x. So let's say if I take x equals 2, what is the y value going to be?
4.
So now what is the next step is we bring small changes and we'll see the changes which also translate onto the y value. So if I make it 2.1, so I'm increasing fractionally by 0.1. How much the y value will become now?
4.4.
Very good. So if I make it even smaller, what do you expect? You can use calculator. So I'm trying to bring a change, but I'm reducing the change. I'm just trying to make the change as small as possible to see the effect on the other side, the dependent variable. So how much I'm getting here?
So 4.0401.
And that's there is a really, very nice pattern actually you will get. No need to use calci next. So sorry. If I get a 2.001, the answer will be 4.0040001. So if you make even a small change, okay, we'll stop here. So let's stop. Now try to realize what is happening. As you bring the change in x, the y will have some changes, but as we make the changes smaller, the change in the y is also becoming smaller. So let's try to find the difference of the changes. Okay, so I'll draw something like this. So the first change was how much? 0.1. But the next change was, the next was, look at the change in the y. And you can again see the similar thing. So the first change was 0.41, but the next was point. Space constant 0.0401, and the next was 0.004001, and the last was, let's say, 0.0040. So every change in x is bringing some change in y. And we can see as you reduce the change in x, the change in y is also reducing. So if the change becomes really small, let's say the change itself is as good as 0, the change in the dependent will be also as good as 0. So we are looking for the ratio. So let's call the change as delta x and the change in y as delta y. So what is the ratio of change del y by del x? So if we take the first case, we will get 0.41 upon 0.1. But in the next case, what we get the same change if we try to find for the next case, this is 4.1. And if you take the change for the next case, it will become how much? 0.0401 upon 0.01. And if you look carefully, this is 4.01. And the next case is how much? 4.001. And the next case is how much? So it means if I keep on reducing, my answer will eventually become 4.0000000 and remotely something one. This is as good as 4, right? Now, those who know differentiation in advance, if you differentiate, you will get dy by dx equals to. Now, those who know, don't worry. This is 2x. And if x is 2, the delta y by delta x becomes 4, which is actually matching with this mathematical manipulation. If you keep on reducing the size of x, the y will also keep on decreasing, and the ratio will approach some finite value, and the answer is going to be 4. So that is the meaning of dy. Dy basically means the smallest possible change. And what is dx? The smallest possible change in the independent variable, and dy is called the smallest possible change in the dependent variable, and the ratio of the smallest change in the dependent variable per unit change in the independent variable, that term we call derivative. So derivative means to derive, okay, and derivative will have multiple meaning. So we have the operator meaning, we have the geometrical meaning, and we have the meaning in terms of change, meaning in terms of approximation. There are many meaning that we are going to attach to this way of writing something in physics. So that is what we'll discuss in the next lecture. Till then, goodbye, take care, and keep on thinking about all this mathematical discussion which happened today. It will benefit you in long run. Bye guys and take care.
Bye, sir. Thank you, sir.